Welcome back, everyone. It's good to be with you to talk about Charles's Law, the second individual gas law for this chapter. Charles's Law is an expression regarding volume and temperature of a gas. And Charles' Law states that if you increase the temperature of a gas, its volume will increase. And that makes sense if you give a sample of gas heat, if you heat it up and give it more energy, those gas molecules move around more, and the volume that they encounter or the volume that they exhibit expands. So volume and temperature of a gas are directly proportional. If you increase the temperature, you increase the volume of that gas that gas sample occupies. Mathematically, that expression is V1 over T1 is equal to V2 over T2, where 1 represents initial and 2 represents final. The other important point from this slide is with regards to units and temperature. So when doing any gas law problems, not just Charles' law, but any of the other gas law problems that we do in this chapter, the unit for temperature must always be in Kelvin. And the reason why that is kind of illustrated in this graph on the right. When gases are at 0 degrees Celsius, they obviously still occupy some volume, as shown here. But if we were to put 0 degrees Celsius in Charles's law, this equation for Charles's law would blow up. When I say blow up, I mean that when you divide something by 0, you get a number that is undefined. You can't have a volume that is undefined. So we need to be able to use Charles's law with a temperature scale that is based upon absolute 0, where the volume of gas is extrapolated to that temperature, because obviously gases at 0 degrees Celsius do still have volume. So when using Charles's gas law or any gas law with this unit, your temperature must be in Kelvin. And that's straightforward enough, because most of the time when you are given temperatures in Celsius, to take that temperature into Kelvin, you take the temperature in Celsius and add 273 to it, and that will give you the temperature in Kelvin. And so that's what we're going to do with our gas law problems, and that's what we're going to do with this next example, which is sample of gas has a volume of 1 liter at 25 Celsius. And I want to know what the new volume is when I increase the temperature to 100 degrees Celsius. Now, obviously, the fact that we are increasing the temperature, we know my volume is going to be bigger than 1 liter. But we're going to use Charles's law to solve, making sure that we take our temperatures that are in degrees Celsius and adding 273 to get our temperature in Kelvin. So once we identify what we're given and taking Charles's law and solving for V2 by cross multiplying and dividing, which is what I've done down here, and then inputting the correct values with their number and unit, and I see my Kelvin units cancel, and I'm left with a number that's going to be in liters. And that final answer is 1.25 liters, indeed larger than what I started with. So that's an example of Charles's law. V1 over T1 equals V2 over T2. Always make sure that your temperatures are in Kelvin.